Hello and welcome back to another video. In this problem, we're told that this table shows average U.S. retail residential prices of electricity from 2000 to 2012, measured in cents per kilowatt hour. So first in part A, we're asked to make a scatter plot. So we're going to graph these points, and we are going from 0 to 12 on the x-axis and 8 to 11.5 on the y-axis. So this isn't completely necessary, but I'm going to start at 8 on the y-axis just so we can see our trends a little bit easier. This is going to go from 0 to 12, so 2, 4, 6, 8, 10, 12. And we can fill those in right there. And from 8 to 12, so this is 10, 11, and 9, and halfway in between them, just to make it easier to graph. So we have 0, 8.24, is right about there, 2, 8.44, 4, 8.95, just under 9, 6, 10.4, way up here, 8, 11.26, 10, 11.54, and 12, 11.58. So is a linear model appropriate? Honestly, I don't really think so. We have not a super constant rate of change. It's very slow at the beginning, then it increases rapidly here, and then it finishes off at the end. We can get a line to fit, so it's relatively close to all these points. So we are going to continue to do it, but I don't think it's the most appropriate model that we could use here. B, find and graph the regression line. So the LSRL, the least squares regression line. This is the line that minimizes the distance, it's actually the squared distances, between the line and all of these points. You can do this by plugging in the points to your graphing calculator, or just an online calculator, and you'll get y is equal to 0.33x plus 8.07. We're asked to graph this, so I think the easiest way to do this is to find another point. So let's say x equals 10. We have y equals 0.33 times 10 plus 8.07. Y therefore equals 3.3 plus 8.07, which is 11.37. So our y-intercept is 8.07, so basically down on the bottom, the origin, and 11.37 is right here. So this is our line right here that minimizes the distance to all the points. And this is sort of the problem. It doesn't super fit what we're actually seeing in the data. If it was drawn a little bit better, we would see that it's a little bit closer than it actually looks, but I still don't think that the best way to demonstrate this data is a linear model. Finally, for C, we're asked to use our linear model from part B to estimate the average retail price of electricity in 2005 and 2013. So 2005 was 5 years after 2000. So therefore it's y is equal to 0.33 times 5 plus 8.07. This is equal to 9.72, roughly. And y is equal to 0.33 times 13 is 13 years after 2000 plus 8.07 is roughly 12.37. So these are the estimated prices if we were to extrapolate. And so that is our LSRL. I did notice that this is the wrong point. That's why it's so far off. This is actually the real line, which is a lot more reasonable. So ignore that line. If I wasn't drawing in pen, I would erase it, but this is our least squares regression line. This is not. This is the actual equation, plotted over all the points, and these are the expected prices 5 and 13 years since 2000 based off of our data.